Assalamualaikum. My name is Muhammad Naqreen bin Muhammad ASRI. Number ID is TE21047.
My name is Muhammad AIMAN bin Muhammad ROSLAN, ID TE21048.
Hi, Assalamualaikum warahmatullahi wabarakatuh. So my name is BINTI MAZUWIRA and my ID number is TE21049.
Theory of FreeFall. In mechanics, freefall is the state of body that moves freely in any direction in the presence of gravity. In the gravitational field of the Sun, the planets, for example, are in free fall. According to Newton's principle, a body in free fall will follow an orbit in which the total of gravitational and inertial forces equals zero. Because gravitational forces are never homogeneous, only the center of mass is free falling, because they move in a slightly distinct gravitational field. All other points of a body are susceptible to tidal forces. The Earth is in free fall, but the Moon's pull at the Earth's surface is not the same as at its center. Ocean tides rise and fall because the oceans are not in perfect free fall.
There are several apparatus that we use for this experiment, which is smartphone with FreeFall apps, measuring tape and clipboard pen, paperclip as an object we want to drop, plasticine. Next, I will explain about the procedure of the experiment. Firstly, we need to paste the measuring tape on the vertical wall. Then, hang the paperclip on the clipboard pen and set the falling distance, for example, h at 40 cm. Next, open the FreeFall and choose acoustic stopwatch under the timer categories and set the value of threshold and minimum delay. When the setup done, press the clipboard pen and let the object fall freely. Then, record the falling time and repeat the step in different value of h.
Precaution of freefall experiment. Sources of error are factors inherent within the experimental setup and procedures that cannot be fixed, no matter how hard you try. For example, if your experiment is intended to determine the acceleration due to gravity of a freely falling object, the effect of air resistance will be one of the source of error. Other than that, during using FreeFall app, our environment must be quiet or silent because this app is very sensitive with sound.
To measure the time, we are going to use the acoustic stopwatch in FreeFall apps. If you did not already install the FreeFall apps, you can get it free on Android and iOS. Choose the FreeFall apps. In the main menu, go for timer and choose acoustic stopwatch. When you start the blinking play button, it will simply count the time between two loud events. Threshold sets the volume at which it triggers. So if it is too sensitive and start because of background noise, increase the threshold. If you miss this event, decrease the value. So for our experiment purpose, we set the threshold as 0.04. Since any noise have a very short durations and reverberations can also be above the threshold, you can adjust the minimum delay to prevent a single sound event from triggering the stopwatch multiple times. If your sound event start and stop the stopwatch right away, you should increase the value. But this event should be always smaller than the time you're going to measure. For our purpose, we are going to set the value as 0.2. In this experiment, we are going to drop an object and measure the time it takes from its release until the impact on the floor. To do this, we need to do triggers to sound event which indicates the drop started and drop ends with the impact. With that, we can use the acoustic stopwatch to measure the time. The click pen being pressed initiate the drop of object would make a noise to start the stopwatch, and the impact on the floor makes second noise to stop the stopwatch again. So with a very simple setup, you can perform the experiment at home.
Observation during the experiment. During our experiment, we observed that the time taken of paperclip free falling to the ground lesser depend on the height level. If the height is decreased, then the time taken for paperclip of free falling is decreased, because an object doing free fall has a constant acceleration, and acceleration is independent of the mass and the height